So good day. Today, we will be discussing the Chapter 1 Lesson 10, Measurement. So, measurement in research consists of assigning numbers to empirical events, objects, or properties or activities in compliance with a set of rules. This definition implies that measurement is a three-part process. First, selecting observable empirical events. Second, developing a set of mapping rules, a scheme for assigning numbers or symbols to represent aspects of the event being measured. Third, applying the mapping rules to each observation of that event. Since quantitative research is different from qualitative, we are assigning, in order to measure the phenomenon, we need to assign numbers in order to quantify its measurement. Variable being studied in research may be classified as object or as properties. So object includes the concept of ordinary experiences such as tangible items like furniture, laundry detergent, people, or automobiles. Object also includes things that are not concrete such as genes, attitudes, and peer group pressures. Properties are characteristics of the object. Person's physical properties may be stated in terms of weight, height, and posture, among others. Whereas, physiological properties includes attitude and intelligence. Social properties includes leadership ability, class affiliation, and status. In a literal sense, researchers do not measure either object or properties. They measure indicants of the properties or indicants of the properties of object, or the indicator. It is easy to observe that A is taller than B and that C participates more than D in a group process. So we are quantifying by means of level, by means of extent. We are assigning numbers out of that characteristics. In contrast, it is not easy to measure properties of constructs like lifestyle, opinion leadership, distribution channel, structures, and persuasiveness. Since property cannot be measured directly, one must infer its presence or absence by observing some indicants or pointer measurement. When you begin to make such inferences, there is often disagreement about how to develop an operational definition for each indicant. So we will be introducing you to measurement scale, or scaling in layman's terms. In measuring, one devises some mapping rules and then translate the observation of property indicants using this rule. For each concept of construct, several types of measurements are possible. The appropriate choice depends on what you assumed about the mapping rules. Each one has its own set of underlying assumptions about how the numeric symbol corresponds to real-world observation. Measurement scale can be 3-point, 5-point scaling, or 7-point, 9-point scaling. It's up to the nature of your study. Mapping rules have 4 assumptions. Numbers are used to classify groups or sort of responses. No order exists. For example, for the demographic profile, male and female. So you are just assigning numbers. One example, 1 for the male and 2 for the female. No order exists. Not male is placed in number 1 or female will be placed in number 2. Numbers are ordered. One number is greater than, less than, or equal to another number. So this refers to the numbering which has orders. Differences between numbers are ordered. The differences between any pair or numbers greater than, less than, or equal to the difference between any other pair of numbers. The number series has a unique origin indicated by the number 0. This is an absolute and meaningful 0 point. So letter A, it refers to the nominal data. B is referring to ordinal data. C is referring to interval data. And D is referring to the ratio. We will be discussing later on those data. Measurement scale. So we have this nominal. Classification, its characteristics of data is classification but no order, distance, or natural origin. All you have to do is name the category. Basic empirical operation, determination of equality. Example, gender or sex, male and female. Ordinal, classification and order. It has order. Compared to nominal, there is no order. But the distance and the natural origin is 0 or no distance or natural origin. And basic empirical operation, determination of greater or lesser value. Example, doneness of meat, well, medium rare, and rare. So it has now the order. Interval, this has a classification, order, and distance but no natural origin. Example of this are the temperature in degrees, scaling, history, weight, height. So it is interval. Ratio, it has a classification, it has the order, it has the distance, natural origin. In its characteristics, in its its determination of equality and ratio. And example are age in years. So it has as absolute 0 or the natural origin. You will start from example age. You will start from 0, 1, 2, 3, 4, 5, 6, 7, 8. So that is an example of the types of data. Sources of measurement differences. So here are error sources. First, the respondents. Opinion differences that affect measurements came from relatively stable characteristics of the respondents. Typical of this are employee status, ethnic group member, social class, and nearness to manufacturing facilities. The skilled researcher will anticipate many of these dimensions, adjusting the design to eliminate, neutralize, or otherwise deal with them. So that's the purpose why in your research you have the scope and the limitation, because you cannot sometimes control everything, especially the respondents. Respondents may be reluctant to express strong negative or positive feelings, may purposefully express attitude that they perceive as different from those of the others, or may have little knowledge about the subject matter but reluctant to admit ignorance. Sometimes, when you do conduct your study, especially when the self-administered study, it's difficult for the researcher to analyze the facial expression since it is self-administered. Whereas when doing the survey, you are waiting for the response of the respondents. You can, or the respondents can ask questions if they have a confusion out of your statements. This reluctance to admit ignorance of a topic can lead to an interview consisting of guesses or assumption, which in turn create erroneous data. Sometimes respondents, it's natural that sometimes respondents has a limited time to answer the survey questionnaire or the study, or sometimes they have a limited knowledge on how to answer the questionnaire. So, careful researchers in that particular error. Respondents may also suffer from temporary factors like fatigue, boredom, anxiety, hunger, impatience, or general variation in mood or other distraction. This limits the ability to respond accurately and fully. So it's the task of the researcher to make the respondent answer in a well-conditioned environment. Designing measurement scales that engage the participants for the duration of the measurement is crucial. So that's why in your questionnaire, you are tasked also as a researcher to undergo validity and reliability in order to measure, in order to simplify those complicated questions, and to shorten those questions, not to appear from the point of the respondents that it will cost too much time in answering your questionnaires. Situational factors. Any condition that places a strain on the interview or measurement session can have serious effects on the interviewer-respondent's report. If another person is present, the person can distort responses by joining in, by distracting, or by merely being there. If the respondents believe anonymity is not ensured, they may be reluctant to express a certain feelings. Curbside or intercept interviews are unlikely to elicit elaborate responses, while in-home interviews are more often do. Sometimes make sure that the respondents, when answering, has its focus on answering, and please avoid if they have companion. Make sure that the respondents is focused on the answering the question, not on the or in his or her companion. The third, the measurer. The interview can distort responses by rewording, paraphrasing, or reordering questions. Stereotypes in appearance and action introduces bias in inflections of voices and conscious and unconscious prompting of smile, nod, and so forth, may encourage or discourage certain reply. So, in your instrument or the data gathering instrument, make sure that it is properly validated and conducted a reliability testing on your gathering data instrument. Careless mechanical processing, checking of the wrong responses, or failure to record full replies will obviously distort findings. In the data analysis stage, incorrect coding, careless tabulation, and faculty statistical calculation may be introduced further errors. So when doing encoding, it's prone for errors. Sometimes when you do encoding in Excel with the small spaces or cells, it's difficult for the respondents not to commit error. So usually it's normal, but make sure to double check and make sure to undergo rechecking. The instrument, a defective instrument, can cause distortion in two major ways. First, it can be too confusing and ambiguous. Sometimes the statements that are vague and has double meaning. So it can cause confusion to the respondents. The use of complex word and syntax beyond participants' comprehension is typical. So when you do the survey questionnaire, so make sure that you know also your respondents. If your respondents are living in rural areas, make sure to translate those English terms into their language wherein they can understand and comprehend the questions well. Or, either in a way that you will have to translate personally when you do the survey. Leading questions, ambiguous meaning, mechanical defects, inadequate space for replies, response choice, omission, and poor printing, and multiple questions suggest the range of problems. So that's why before you will have to conduct your study, you need a proper guidance from your advisor, English critic, and the juror for validity and reliability, and also for your statistician. Many of these problems are the direct results of operational definition that are insufficient, resulting in an inappropriate scale being chosen or developed. Second, a more elusive type of instrument deficiency is poor selection from the source of content items. Sometimes this is visible to most of the researchers when they look for their data gathering instrument or content or ideas for their research instrument. Sometimes they have this overwhelming emotions to have copy-paste all the information, in which sometimes some of the contents are not applicable to the study. The characteristics of good measurement. 3 major criteria for evaluating a measurement tool: validity, reliability, and practicality. So validity is the extent to which a test is measured, what actually with to measure. So in doing validity, the jurors will have to evaluate using the Gudin-Skate or the Lao-Shi evaluation tool in order to scrutinize the content if it is applicable or not applicable with the study. Reliability has to do with the accuracy and precision of the measurement procedure. The purpose of reliability, when you do conduct this study from this group and to another group, they have similar or almost similar answer. Practicality is concerned with a wide range of this quality and how researcher can achieve them, and interpretability. So, if your questionnaire is past all this type of evaluation, then you are good to go. So, the content validity testing, what is measured? The degree to which the content of the item adequately represents the universe of all relevant item under study. So, the content validity measures that all the content are appropriate for the study. Criterion related, degree to which the predictor is adequately in capturing the relevant aspect of the criterion, or you have what we call criteria in your survey instrument. Concurrent description of the present criterion data are available at the same time as predictor scores. Prediction of the future criterion data are measured after the passage of time. Construct, how you package the survey questionnaire. Answer the question, what accounts for the variance in the measure? Attempts to identify the underlying construct being measured and determine how well the test represents it. So, content validity, this approach to ascertaining validity simply relies on the judgment of the expert in the field of study as to the comprehensiveness, appropriateness, and adequacy of question items on measuring elements of the construct falling under a phenomenon. So, as long as it is appropriate, the expert will evaluate all the sentences. If it is crafted and structured appropriately, then it will have a high score. Thus, it is the extent to which the questions of on the instrument, and the scores from this question represent all possible questions that could be asked about the content or skills. It ensures that the questionnaire includes an adequate set of items that tap into the concept. Face validity. It refers to the extent or degree an instrument could measure it deems or intend to measure. This approach heavily relies on the familiarity and experience of the instrument assessor on the subject matter without strong requirement as to reference with to establish theory. So usually, if face validity is for the what is the appeal of the questionnaire to the audience. Criterion related validity. This test established the validity of the researcher-developed instrument by correlation of the result to standard or previously validated instrument by administering both tests on the same phenomenon. Sometimes, if you have a questionnaire that is similar to other questionnaire but the content is different, then you will have to do the criterion-related validity testing. If the result of two groups will be the same, then therefore, your questionnaire is good as with the existing questionnaire. According to Palant, 2011, this validity approach utilizes relationship between scale scores and some specific measurable criterion. It tests how to scale differentiate individual on a criterion it is expected to predict. Convergent validity. This is established when two instruments directed to measure similar concept or construct share high correlation. The same with the previous validity testing, which is if we have the criterion, the criterion validity testing, if the criterion has this criteria, the convergent validity is the comparison of two questionnaires if they are highly related or not related at all. According to Messick, 1995, this refers to the extent to which scores on a measure share a high, medium, or low relationship with scores obtained on a different measure intended to assess the similar construct. If it is highly related, then your questionnaire is properly constructed and can be utilized for the study. Discriminant validity. Unlike convergent validity, which tries to determine the validity by strong correlation of the concept, this discriminant validity tries to establish the lack or absence of relationship between variables, which by theory are not related and which is affirmed by the testing. There are some study that the questionnaire that needs make sure that the questionnaire is not related or new to the existing questionnaires. Lauschy content validity. The content validity ratio, or the CVR, which is suggested by Lauschy in 1975, is a widely used index to quantify content validity. In this study, the Bayesian approach is used to determine the minimum number of experts required to agree an item is essential, and then the CVR is calculated. Content validity evaluates how well an instrument, like a test, covers all relevant part of the construct it aims to measure. Here, a construct is a theoretical concept, theme, or idea in particular, one that cannot usually be measured directly. So the formula for Lauschy is CVR, content validity ratio, NE minus N divided by 2 over N divided by 2, wherein NE is the number of the panelists indicating essential, not essential, essential but not important. N is the total number of the panelists. Each question in the questionnaire will be evaluated by the expert and categorize the question as essential, essential but not useful, and not necessary. Number of expert, if we have 6, the minimum value supposedly will be 0.99 or higher. Number of expert 8. The minimum value is supposedly 0.78 or higher. If the expert is 10, 0.62 or higher. Number of expert 15, 0.49 or higher. Number of expert 20, 0.42 or higher. 25, that's 0.37 or higher. And 30, expert, the CVR must be 0.33 or higher. So the higher the expert evaluating your questionnaire, the minimum or the lower the minimum value required. So reliability, this measure the consistency of the result with the use of the survey instrument. So the test and retest, this is if it is or it has a reliability of a test or instrument inferred from examinee score. Same test is administered twice to the same subject over an interval of less than 6 months. So that way you can test your questionnaire if it is consistent or not. Parallel form, equivalence, degree to which alternative form of the same measure produces same or similar result. Administered simultaneously or with delay. Interpreter estimates of the similarity of judges' observation or score. So, you can have these two groups. You will have to give them simultaneously the two different questionnaires. If they bear almost or similar result, then your questionnaire is highly reliable. This is the most common, the Cronbach alpha. Degree to which instrument specialized items are homogeneous and correlational reflect the same underlying formulas construct. So all you have to do is to look for 30 respondents for reliability testing. Make sure that the 30 respondents are not included in your targeted respondents in the conduct of the actual study. So they are just the same characteristics of respondents but different respondents. So thank you very much for your listening.